Okay. So we're going to start right here on page 1 of our notes. It says there are 2 types of special right triangles. The first one is the 45, 45, 90. What do we know about it? We know that it has 2 congruent legs and 2 congruent angles. Because you're not always going to have the angles marked as 45. Sometimes they're going to be marked as congruent. Okay. You're not always going to have that your angles are 45, 45. Sometimes you'll just have congruent marks. So I want you to know that. Okay. Well, we just learned that if the leg is X, if we call the leg X, then the hypotenuse is X times the square root of 2. I want to tell you how I remember that. I remember that the hypotenuse is always the short leg times the square root of 2 because we have 2 congruent sides. Or you can think of it as 2 congruent angles. That's why I know I'm using the square root of 2. Because it gets confusing. Like, is it a square root 2? The hypotenuse is, like, you only have 2 measures here. One side's X, the other one has got a radical in it. The hypotenuse is the square root of 2 because it's not one of the 2 sides. And then we know that when we have the 30, 60, 90 triangle, a lot of times it doesn't put 30 and 60 both in your triangles. Most often it just gives you the right angle and then one of the measures, either a 30 or a 60. Not always both, okay? So what do we know? Well, if the short leg is A, and I'm using the variable A just because when I keep using the same variables over and over again, you guys get confused. We know that if the short leg is A, then the hypotenuse is 2 times that, or 2A, and the long leg is A times the square root of 3. I remember that the long leg is this. Is the short leg times the square root of 3 because, are you guys okay if I do B/C again? Because all 3 sides are different. That's how I remember that this one has like a 3 in the radical. All 3 sides are different. All 3 sides are different. So for the first 2 examples that we do, I'm going to use Pythagorean theorem because we have some kiddos that are absent and I didn't make a video of our little like pink sheet. Does that make sense? So for example, 40, for this first example right here, I need to find P and R. I need to find P and R. Well, because both of these angles are congruent, I know that the sides opposite of them are congruent. So P is also 7. Good job. So let's see. 7 squared plus 7 squared equals my hypotenuse, which is R squared. But 7 squared is 49 plus 49. So that's 98 equals R squared. And when I take the square root of both sides, remember that all I did to get to 98 was I took 49 times 2. So I can break this up as the square root of 49 times the square root of 2 equals R. but we know that the square root of 49 is 7. So 7 times the square root of 2 equals r. So we did the Pythagorean theorem for that first one, that first 45, 45. We okay?
This one, 38 square root of 2 equals r.
So let's look at the next one.
Same angle, so
These are the same. These legs are the same. So just decide, do you want to use y or z as your variable for your leg? Okay. So z squared plus z squared has to equal 8 squared.
Oh.
Well, z squared plus z squared is 2z squared equals 8 squared is 64. So I divide both sides by 2, and I find out that z squared equals 32. Take the square root of both sides. And when I do that, I know that z equals, well, 32 is the same thing as the square root of 16 times the square root of 2. So z, my leg, is 4 root 2. That's both of these. Both of these are 4 root 2 because they're congruent. So I wrote a little rule, which we've already put on our paper, but I'm going to write it again. And I wrote it like this. Rule 45, 45, 90. The leg equals the hypotenuse times the square root of 2 over 2. If we had used that rule, what is 8 times the square root of 2? Well, it's 8 root 2. Divided by 2 is 4 root 2. So if we had used that rule, we would have 8 times the square root of 2 over 2, which equals 4 root 2 for my legs. Okay? So I'm just trying to show you that there are ways to not always have to do the Pythagorean theorem. So those are for your 45s. For your 30, 60, 90, if you're only given one side, you have to know, like you have to commit the 30, 60, 90s to memory. And I'm going to let you use your, we're going to do a foldable next week. I don't think we'll have time to do it tomorrow. We'll do a foldable next week that I'll let you use on your test, but I'm not going to let you use that pink sheet. Okay. So let's look at this first example right here of a 30, 60, 90. Are you okay? So here's a 30, 60, 90. Which one is the short leg? So you have a short leg, a long leg, and a hypotenuse. I always start with that. So remember the rules for the 30, 60, 90. Well, the long leg equals the short leg times the square root of 3. So my long leg equals 2 times the square root of 3. And the other rule that you learned is that your hypotenuse equals 2 times your short leg. That means that your hypotenuse equals 2 times 2, which is 4. So your hypotenuse is 4, and your long leg is 2 root 3. We have one more 30, 60, 90 right triangle, and it's this one right here. And this tells us that the hypotenuse is 6. We need to figure out what the long leg and the short leg are? Trey, what did you discover about the hypotenuse and the short leg? How are they related? So to find the short leg, I take the hypotenuse and divide it by. So the short leg is 3. And if the short leg is 3, then my long leg is my short leg times the square root of 3. So my long leg is, yes, 3 root 3. So do you guys see that these all are related to the variables at the bottom? So P is from the first triangle is 7, and R is 7 times the square root of 2. V is from the second triangle, or sorry, Y is from the second triangle, and so is Z, and they both have the same measure, 4 root 2. S is from the third triangle that we did. S was my long leg. My long leg is 2 root 3. And T is my hypotenuse, and my hypotenuse is twice the short leg. So that is 4. And then the last two variables, X and W, they came from the triangle that I just did in green. So X is the short leg, which we know to be 3. And W is the long leg, which we know to be 3 root 3. We're going to do 6 more examples, and then I'll get you guys started. 6 more examples. So flip over to page 2. Flip over to page 2. Okay. So what am I given? What measurement do I know? Is it a short leg, long leg, or a hypotenuse? Yeah, this is a long leg. So I know that the short leg equals the long leg divided by the square root of 3. Or, hang on a second, it equals the long leg times the square root of 3 divided by 3. The only time I use the divide by square root of 3 is if it's got a square root of 3 in it, right? And they cancel out. So which one of those steps am I going to use? Yeah, I need to use the second one. So the short leg equals the long leg, which is 25 times the square root of 3 over 3. And you cannot simplify that. That has to be left as this ugly fraction. You cannot simplify that. If we know the short leg, can we figure out the hypotenuse? Yeah. Remember that the hypotenuse equals 2 times the short leg. So that's 2 over 1 times 25 root 3 over 3. So what is my hypotenuse? Well, what's 2 times 25? 50. So 50 root 3. And 1 times 3 is just 3. Okay, so we just leave it like that. We don't try to simplify that. You're going to get repeating decimals and just all kinds of mess stuff. You don't want to do that. What kind of triangle is this next one? What special right triangle? Is it a 30, 60, 90 or 45, 45, 90? You with me, Luke? Because it looks like you're sleeping. What kind of triangle is this? Well, both of these sides are marked as Y, which means that they both have the same measure, which means that they're congruent, which means that these are 45s because the angles are congruent. So this is a 45, 45. If I want to find the leg, I take the hypotenuse and divide it by the square root of 2, or I take the hypotenuse times the square root of 2 all over 2. Which one of these am I going to use? What method am I going to use? The second one again, because my hypotenuse doesn't have a radical in it, right? So my leg equals my hypotenuse, which is 28, times the square root of 2 over 2. But what is 28 divided by 2? So 14 square root 2.
That's 196.
No, it's not. It's 14 square root 2. I'm not asking you to square 14. I'm saying 14 times the square root of 2. Okay, what kind of triangle is this? Yeah, these have two 30, 60, 90s, and we're trying to find the hypotenuse. What do we know? What are we given a measurement for? No, we're given the side measure for the long leg. We know the long leg. So if we want to find the short leg, we have to take the long leg times the square root of 3 divided by 3. So my short leg is what? Well, my long leg is 14 times the square root of 3 divided by 3. You can't simplify that. 14 is not divisible by 3, so you just leave it like that. Now I need to find the hypotenuse. And my hypotenuse is 2 times my short leg. So 2 over 1 times 14 root 3 over 3. So 2 times 14 is 28. 28 root 3 over 3 is the measurement of your hypotenuse. All right, Nathan, you're up. Talk to us about number 4. What does the variable that you're trying to find represent? The leg or the hypotenuse? Yep, this is a hypotenuse. Because it's a square, these are congruent, right? So this is 45, 45. How do you find the hypotenuse if you know the leg? Look at your 45, 45 rules. The hypotenuse equals what? The leg times, what do the directions say? You can either look at your pink sheet, the hypotenuse equals the leg times the, yeah, the leg times the square root of 2. Well, what is the measurement of the leg? So I have the square root of 2 times, which is,
16.
what is 2 times 2? So it's the square root of 4. It's the square root of 2 times the square root of 2. This is a 45, 45, right? Okay, so what is the square root of 4? 2.
Oh.
So your hypotenuse equals 2. Okay, Edgar, you're up. So Edgar, what kind of triangles do you have presented there? Are they 30, 60, 90 or 45, 45s? Yeah, you know that because these sides are congruent. This is the exact same as the one that we just did, but in reverse. So now you're trying to find the leg. So I know that if I want to find the leg, I do what with my hypotenuse? And divide it by, okay. Who was that? Who said that? Good job, Edgar. Your voice seemed a little bit deeper than typical. So what your hypotenuse is 6 times the square root of 2 divided by 2, which is what? What is that? It's 3. So 3 root 2 is your leg. 3 root 2 is your leg because 6 divided by 2 is 3. Perfect. Okay. Garrison, you ready for number 6? Number 6? It does look scary. Who said they can do it? Tyler, you got it? Oh. What if I do this? What if I kind of turn it into a triangle? So you know that if this side right here is 2 times the square root of 3, then this is also 2 times the square root of 3. So then could you figure out what A is? Okay. So what is 2 root 3? This is a 60, 30, 60, 90. So is 2 root 3 the long leg, the short leg, or the hypotenuse? It's the long leg. So if I want to find the short leg, let's see. If I want to find the short leg, I take the long leg divided by the square root of 3. So the short leg equals 2 root 3 divided by the square root of 3, which is just 2. So that means that this measure right here is 2. So if that measure right there is 2, then what is the measure of B? Because the whole side altogether is 5. Good job. 5 minus 2 is 3. So B equals 5 minus 2. So B equals 3. All we need to do now is find A. How are we going to do that? That's my hypotenuse. Well, on a 30, 60, 90, my hypotenuse equals. Say it again, Tyler. Isn't it short leg times what? I'm on a 30, 60, 90. Hypotenuse, 30, 60, 90. Short leg times 2. So my hypotenuse is 2 times 2, which equals what? 4. Your hypotenuse equals 4.